Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. Whether we're talking about the current state of things with the coronavirus pandemic that struck the world in 2020 or the evolution of Internet of Things, there are considerations that we need to look at with remote workers. Internet of Things, or IoT, refers to devices that you can access and control via the internet and devices that connect directly to the internet resources. This can be lights, smart thermostats, or all kinds of other devices. In a remote worker's house, it's likely that they have some type of IoT automation. Even if it's just as simple as some smart home light bulbs, it's there. They might even have a smart printer or a multifunction device, MFD, that connects directly to the internet. There's also home security systems like the Ring doorbell that are IoT devices. Zigbee and Z-Wave, which support over 64,000 devices at the 2.4 gigahertz or 915 megahertz bands, and the proprietary Z-Wave protocol, which supports 232 devices and uses the 908 and 916 megahertz bands. Wi-Fi can be used when manufacturers don't worry about the power consumption that these devices take. Bluetooth is another technology that uses a discovery mode to create a small personal area network, or PAN, to connect devices together. IoT security is another concern. You have to keep devices up to date with the latest software and firmware. If you're using IoT cameras, limit physical access to them. Place all the cameras in their own SSID. Have camera feeds on their own VLAN. Use strong passwords or pre-shared keys. Routinely check for software and firmware updates. Restrict the users who can log into the devices. Basically, you should protect physical access and network access to these devices. Believe it or not, telephone calls in companies rarely are using traditional phone systems. Instead, voice over IP, or VoIP, allows voice traffic to travel over IP networks and use the internet to make and receive calls. Some systems like Skype are entirely ran over the internet. However, some systems use VoIP gateways or voice gateways to interact with PBX systems, which are the traditional phone systems that you're familiar with. The two main protocols that VoIP uses are Real-Time Transport Protocol, RTP, which is UDP, and it's recommended to use ports 6970 and 6999, but that's not a requirement. The other one is Session Initiation Protocol, or SIP, which uses TCP or UDP ports 5060 and 5061, with port 5061 using Transport Layer Security, or TLS, to encrypt that traffic. Make sure that you remember the term SIP trunking, which allows you to connect PBX or phone systems from multiple locations seamlessly over the internet via virtual connections called SIP trunks. Unified Communications, or UC, is a broad term for this style of communications that brings in some additional features other than just making and receiving calls. Cisco is one of the market leaders in this area. Some of the features and services that Unified Communications allows are called real-time services, or RTS, and they include presence information, like if you're away from your computer or you're available, video conferencing, fax, messaging, and collaboration tools. UC networks use specific components to work. UC devices are the devices like the telephone that we use to make VoIP calls or video calls. UC servers are a dedicated box that supports the UC services. Depending on the size of the network, you could have one or multiple of these boxes, and they're typically on their own VLAN. UC gateways are an edge device, and typically they're actually installed on a router to add additional services so that they can interface with remote UC gateways and PSTN or regular phone systems and services. Unified Communications also uses SIP and RTP protocols, but it can also use H.323 and MGCP. H.323 is used for video presentation as a codec, and it runs on TCP port 1720. Media Gateway Control Protocol, or MGCP, is a complete VoIP or video presentation connection and session controller instead of having separate codecs and parts like H.323. MGCP uses TCP ports 2427 and 2727. Media nets are a network of routers and servers that provide enough bandwidth for video teleconferencing services. Sometimes they work with unified communication servers, but they provide the right level of bandwidth using quality of service, or QoS, which is basically a way of prioritizing data traffic. DiffServ are differentiated services is the underlying architecture that makes all this quality of service work. DiffServ consists of two different pieces of data included in every IP header on all data. The first piece is DSCP, Differentiated Services Code Point, which is 6 bits, and then ECN, Explicit Congestion Notification, which is a 2-bit field that basically signals to other quality of service devices that there's congestion encountered. I wouldn't worry too much about these for the exam. Unified Communications as a Service is a single service that can offer all the unified communications that you need. Users have an application installed on their computer, and the provider does all the work in the cloud. Zoom, WebEx by Cisco, and Microsoft Teams are 3 popular provider options for this service. Industrial Control Systems, or ICSs, are special systems that can control a lot of your building type systems. For example, temperature systems, heaters, pumps, and the list goes on and on. Traditionally, these systems were standalone networks, but today, these systems are starting to connect to the internet to make monitoring more accessible. The downside of that is that we've also seen companies having these systems hacked and leading to further compromise of the rest of their networks. ICS systems are made up of 3 different parts. You have the input-output, the I/O functions on a machine, a controller, and the interface for the operator or user. Now let's talk about distributed control systems. Historically, you would have a controller that was a single computer, which helped save the cost of buying a lot of controllers or computers. Distributed control systems, or DCSs, allow us to put smaller controllers directly onto machines so that the compute load is distributed. The local controllers connect to a centralized ICS server or controller where global changes can be made. All of this is thanks to the decrease in cost of computers. Whenever an operator needs to interact with controllers, they do so through a human-machine interface, an HMI, which are specialized systems and displays with limited functionality for their purpose. Programmable logic controllers, or PLCs, are computers that control machines using a specific set of ordered steps. Compare this to something like an assembly line where the process is very defined. Supervisory control and data acquisition, or SCADA systems, are a subset of ICS. SCADA systems are similar to a DCS, except they're designed for large-scale distributed processes like power grids, pipelines, and railroads. Since they deal with larger distances, they have to assume that remote devices may or may not have ongoing communication with the central control. Remote terminal units, RTUs, replace controllers for SCADA systems. They have basically the same functionality, except RTUs have a certain level of autonomy if they lose connection with the central control, and RTUs are designed to take advantage of long-distance communication systems like telephony, fiber optic, or cellular WANs. Because of this capability, a real concern is the ability to intercept SCADA communications. Of course, traditional segmentation includes physically separating the network, separating devices into separate VLANs and broadcast domains, separating devices into subnets, and using things like VPNs. SCADA systems are known to use public wireless networks and even the internet, so it's an absolute must to use a VPN connection with SCADA systems. Network segmentation is really important to use with SCADA systems.